So what's a polynomial function? So polynomials are a family of functions in math, specifically usually talked about in an algebra class, where there are some basic things going on. So you can have any sort of coefficients you want. So the coefficients of a polynomial, the numbers next to the variables, can be anything. They can be rational numbers like whole numbers or fractions, or they can be irrational numbers like a square root, like the square root of 2. But the specific thing that makes a polynomial is it's the sum and difference, so adding and subtracting, of variables where they all have positive whole number exponents. Right, so some things to make sure of is that all variables need to have positive whole number exponents. In other words, they need to have positive integer exponents. So that means that there are no square roots of variables, or higher, right? So there are no cube roots, no fourth roots, no roots of variables. I'm just going to write square roots as my example. And there are no variables in the denominator of any fractions. And we don't need that there. Denominator of any fractions. I wish I could write as fast as I could speak. Right, so for example, if we look at something like 3x to the 4th plus pi x cubed minus the square root of 3x squared minus 15x plus 2, right? That is a polynomial. Right, so the coefficients can be square roots or irrational numbers like pi that never end, or the square root of -3 is also irrational, the decimal never ends. But all of our variables have positive whole number exponents, right? We have 4, 3, 2, we have an exponent of 1 there, and then no exponent on the 2. Something that is not an exponent would be something like 5x to the 5th minus 4x cubed plus 2x to the -2 power minus 10. So because of this -2, this one is not a polynomial. So some different ways that we categorize polynomials are by the number of terms and by their degree. So degree refers to the highest exponent inside a polynomial. And my iPad froze, so please ignore that. We'll open that back up. Okay, and of course it deleted the L. Okay, so the two ways that we classify polynomials, we're going to go through some review vocabulary, is one, we do it by their degree. So their degree is the highest exponent in the problem. So it's the highest exponent on any variable. So typically in algebra class, we'll only look at single variable equations since those are the ones that we can graph. But just as a heads up, if there are multiple variables, you're going to add the powers of any single term to get the degree. So for example, if I have a term that is 5x to the 4th y cubed z squared, my degree is going to be the sum of all of the exponents in that term. So 4 plus 3 plus 2. So my degree for that term would be 9. And if I had multiple terms that were being added and subtracted, I would do that for each term, and the overall degree of the polynomial would be the highest number. But for the most part, we only look at single variable problems in like Algebra 1 and Algebra 2, so just really x's, because that's what we can graph on the graphing calculator or on the Desmos graphing calculator online, whatever you're using to graph, or by hand. So we have different vocabulary words for different degrees. So if we have a 0 degree, right, we call that a constant. Right, so that's just a number, right? So like y equals a number, right? There are no x's in our problem. If we have a first degree, we call that linear. So that would be something like 2x plus 1. My opening parentheses are always so bad. Okay. Right, second degree, we call a quadratic. Something like x squared plus 2x plus 1. Right. Degree 3 is called a cubic. Something like 4x cubed minus 5x plus 7. A fourth degree is called a quartic function. Think 4 quarters in a dollar. Something like x to the 4th minus 3x squared plus 2. And then our fifth degree is the last special term that we have. If you have like an x to the 5th power, we call that a quintic function, a quintic polynomial. And that could be something like, I don't know, negative 2x to the 5th plus 3x squared minus 7. I'm just making them up. So anything higher, so if you're greater than 5, so say like you're like a 6, a 7, an 8, anything like that, we call that an nth degree. So if we had an x to the 6th as our highest power, we would say that's a 6th degree polynomial. Highest exponent is a 7, that's a 7th degree. Highest exponent is a 10, it's the 10th degree. And we go on from there. So we can also classify polynomials by the number of terms they have. Right? So one term is called a monomial. Right, so that's going to look at something like 2x. If we have 2 terms, that's called a binomial. So something like 2x minus 3 is a binomial. If we have 3 terms, we call that a trinomial. Oh my goodness, my pen does not want to work. There we go. So that could be something like 5x to the 6th minus 4x squared plus 1. So they don't have to have the exponents being in order, and you can like skip them and stuff, doesn't matter, right? We have 3 terms, so we have a trinomial, and then if we have 4 or more terms, so 4 plus terms, we just call that a polynomial, right? Poly meaning many terms. Right, so something like, I don't know, 7x to the 5th minus 4x cubed plus 5x squared minus 7. Right, so we have 4 terms there, so that's a polynomial. So some other things that we might be concerned about with polynomials is looking at their end behavior. And end behavior is really asking the question, what is happening to the graph? So what is happening to the y values on the far right side and the far left side of the graph? So when you're asked to evaluate the end behavior or to analyze it, you're really asking what's happening on the left and right sides of the graph. And so we can figure that out using just the equation, or of course you can look at it on the graph. So the notation for this is for the right side, we say as x approaches positive infinity, right? F of x or y, depending on what your book uses or what's being used in your example, f of x is going where? So that would be the right side of the graph, because the right side of the x-axis is where x is the positive side. So you're saying as x gets more and more positive, x is going to positive infinity. So x is getting really big to the right. What is your function doing? And so you have two options. You can say it's going up. So if it's going up, that's positive infinity. Or you can say it's going down, which means that it's going to negative infinity, right? You're going more and more negative. We also want to look at the left side. So the left side of the graph is where x is negative. So we're going to say as x gets more and more negative, so as x approaches negative infinity, again, what is your function or your y value doing? And you would again fill in that blank using those same two options. Is the graph going up to positive infinity or down to negative infinity? So this is the left side of our graph. So there are two things that you want to look for in an equation to determine the end behavior. So the end behavior is determined by the degree and the sign of the leading coefficient. Which I abbreviate as LC. So the two things that you need to look at, the degree and the leading coefficient, really break down into two camps. So for your degree, right, you can be even or odd. Right, so an even degree is a degree of 2, 4, 6, 8, 10, so on and so forth. Or you have an odd degree value, right, so a degree of 1, 3, 5, 7, so on and so forth. You should know what even and odd numbers are. So if your degree is even, right, the two ends match. And if they're odd, right, the two ends are opposite. So one end is going up, one end is going down. Right, and then the leading coefficient, right, you're looking, is it positive or negative? And what the leading coefficient does is it tells you what the right side of the graph is doing. It's always the right side. So if the leading coefficient tells you the right-hand side, you can use the type of degree, whether that's even or odd, to then say, what does the left side do? If it's an even degree, the left side's going to match the right side. If it's an odd degree, the left side's going to be opposite of the right side. So I'm going to do an example. So we're going to find the end behavior of this function. And bear with me because it's a super, super long one, but I think that's even better because it gives us a lot of talking points. So for this equation, our function is 42x to the 5th minus 231x to the 4th minus 966x cubed minus 7,840 plus 2,772x squared, not done yet, plus 3,192x plus 7x to the 6th. Great, so let's just go ahead and analyze this totally. Let's classify it using our vocabulary and look at the end behavior. So what we want to do first is, I'm going to find my highest degree. So my highest exponent is 6. So I'm going to circle that term so it stands out. Right, so this has 1, 2, 3, 4, 5, 6, 7 terms. right? So this is a polynomial, and our degree is 6. So we have 6th degree. So in terms of finding our end behavior, right, we have an even degree, right, because we have a 6 as our degree. And then our leading coefficient is positive 7. So when we go to find our end behavior, I'm going to write our two statements down. So as x approaches positive infinity, f of x, right, or you might use a y there, approaches what? And as x approaches negative infinity, again, what is f of x, your y value, doing? So remember, this is the right side, and this is the left side. So the leading coefficient always, always, always is going to match the right side. So since our leading coefficient is positive 7, that tells me that on the right-hand side of my graph, my y-coordinates are going up to positive infinity. So on the right side of my graph, right, I don't know what my graph looks like necessarily, but on the right side, it's going to be facing up. Now, I have an even degree, which tells me that my two sides match. So because my two sides are going to match, that means the left-hand side of my graph is also going to go up to positive infinity. Now, if I had a 5th degree polynomial, it would be opposite. So then I would say it's negative infinity. So you just want to look at the first thing that you really want to find is the leading coefficient, because that tells you the right-hand side. And then the type of degree, even or odd, tells you whether or not the